Now we're going to take a look at perspective number 2 as it relates to simple harmonic motion, and that's forces. The thing about forces is there's really not a whole lot of stuff that we do that's really just independent, forces all by itself when it comes to simple harmonic motion. In fact, forces is the bedrock of what simple harmonic motion is. And because the force is constantly changing in time, it makes it very difficult for us to adopt forces as its own unique perspective as we relate it to simple harmonic motion. So what's going to end up happening is we're going to utilize forces through work and energy and impulse and momentum. In fact, it's just going to be work and energy, and I'm going to explain here in just a second why that is. So what I'm going to do is just give you a basic overview of what force looks like for simple harmonic motion, and then we'll take a much closer look at it through some case studies. So the first thing I want to do is construct a couple of graphs for you. The first graph is going to be a force versus position graph, so force versus x, and then we're going to look at force versus time. Okay, and on the force versus position graph, we know that force should be linear. It's a linear restoring force, and so that's going to graph out as a straight line. And this is not how we see things happening. We see things happening through time. And so the force is not going to be linear looking in time, but it is linear with respect to position. So just go back to Hooke's law. So the force versus position graph was useful, if you recall, for work and energy concepts. So this is going to help us out with work and energy. And the big idea to take away from this is that the area of the graph, the area is equal to the work done. All right, we can go in the opposite direction, heading towards the negative amplitude. So, here we might have minus the amplitude, and here we would have the plus amplitude. All right, and so we have area is equal to work. That's very, very helpful for us. Now, force versus time, that's not constant, okay, or constantly changing, I should say. In time, we end up with something that is more sinusoidal. And so that's the rub. It's not that it can't be worked with. It's that in order to determine anything useful, we have to use calculus. Okay, so you'll recall from our studies in impulse and momentum that the area under the curve, this area here, and this area here was equal to the impulse. So area was equal to impulse. But in order to study that in a meaningful way, we have to use calculus. And so we're not going to be doing that. Okay, so like I said, this was going to be a really short video, and it was. I just wanted to point out that force looks differently whenever you have force versus position compared to force versus time. And that because we have the ability to work with force versus position, we will use the concepts of work and energy to more fully develop what's happening with simple harmonic motion. And with force versus time, it requires calculus, and it makes it difficult for us to develop ideas in simple harmonic motion. So in the next video, we're going to look at some work and energy concepts.